Hey everyone, my name is Maxim. I'm one of the developers of Dragonereum game, and I would like to share the experience of the launch. The principal issues we faced, the principal ways to get around them. So let's start with the principal thing, with the principal idea. Our purpose was to build a truly decentralized game where users have their own digital assets, eggs, dragons, and when users can, well, roughly speaking, there is some governance, and they can affect further development of the game. They can impact further development of the game. These are the figures for you to understand the scale of the product, of the project. There are 36 SCs, all of them open source. You can pull them up at our GitHub resource. Free license, use it as you please. Line of SC code, 7,000 lines, 7K plus. Around 100K in front-end code. Unique dragon assets, around 2,500. That's parts of dragons, dragon body parts that can help you create dragons. Wings, other stuff, the patterns of dragons and so on. The patterns as in the coloration scheme, how they colored. Ultimately, this is the number of unique dragons. Of unique dragons that can in theory, be featured in the game. After 1 year of very challenging development, we went to production. The block 6790679, we started the distribution. 2 weeks passed. These are the games that we have achieved. Over 2/3 of Genesis eggs have been claimed. So probably around 3,000 eggs are still unclaimed. You can rush in to pick them up. This is the eggs distribution data. As you can see, there used to be a mad gas price. Now it has stabilized a bit. Used to be up to 400 guefs to pick up an egg. Now it's around 3.9. It's stabilized. There were more than 12K fights fought since launch, and 44K transactions all in all. Top 3 SCs were burning around 15% of all Ethereum gas within the first week. So we were topping the charts in gas burners. Well, sometimes we were second, going up, going down, around the top, which I believe is a favorable, quite a good result. In 2 weeks' time, post-launch, we have had this leaderboard on there. Valera is there. Yeah, your dragon is there. Congratulations. So basically, the leaders come and go. I mean, there's a lot of rotation in the charts. There are quite a lot of dragons that have reached level 10, and they are selling their peaceful skills. They can earn gold based on their peaceful skills. The launch has been pretty intense. I would like to share some experience that we've accumulated in that regard, DAP in production. The first advice, deploy the contracts at least 3 days before the release, or possibly even earlier. Not like us, last minute. Don't deploy SCs at the last minute, because it can take some time. It can take time, or something can go wrong. Well, if something can go wrong, it will go wrong. Keep this Murphy law in mind, because it will hunt you down. You will have to operate things, you'll have to fix things in a very prompt manner. So don't rely on Infura. That's another advice I can share, another piece of advice. The majority of DApp are using the Infura application infrastructure. The thing is, Infura is not reliable at that. And their balancer, or the matchmaker, a balancer is not exactly correct in balancing the load, in allocating the queries. Sometimes the data might be inconsistent for the users. So use the Web3 current provider to only sign the transactions. To get the data from the blockchain through a different algorithm. Use the nodes, use your own nodes, which are stable, which are reliable. Don't rely on Infura. Let's talk about reaching decent level of decentralization, true decentralization. First of all, the entire digital apps logic is fully on-chain. It must be on-chain, all of it. All our SCs are open source. Feel free to have a look at them. Feel free to consider the game mechanics, so it's as transparent as it gets. The game mechanics is very transparent. Second bit, it's got to be open source. I've mentioned it. It helps people understand what's happening in the game and how. IPFS, the content distribution. The issue of the applications that exist are mostly about this. They position themselves as a DApp. However, they cannot really be called decentralized DApps. They cannot really be referred to as DApps, proper DApps. They use servers for data caching. They use servers for rendering pictures. All they do is use SCs to interact for gaming logic. That's all there is to them from DApps. All the rest I've mentioned. Static stuff happens on their own in-house servers. Rendering server-side is also something they use. And that could be a potential hacking site. That server can be hacked. So the developers can change the appearance of an asset, and nobody can affect that. Nobody can influence that. So, right. So the static content, which is stored on a server somewhere, it's not about us. Everything, all the assets of ours are stored in IPFS. Another vector of attack is centralized DNS. Centralized DNS can be solved through ENS. Also, we have the Dragonereum.s, which is in hash IPFS, implemented in hash IPFS. And the last bit here is the in-game governance, inter-game governance. Once we've handled all the vectors, there is this ultimate bit. The developers can still affect smart contracts. The governance is coming soon. We're working there, working to get there. This will be the stage of complete decentralization, where the community can hold the reins to channel our game's development. Why it didn't happen until now? Well, the game was recently launched. Could be some bugs that will need to be promptly dealt with by the developers. So, in the coming days, we're planning to introduce governance. When we started developing the SCs, well, we proceeded from the centralized solutions with some production standards, some established production standards, as good development practices. Mediator and facade, these are the patterns which are pretty often used in the conventional centralized Java-based or other software coding languages involvement. And those projects use them. SCs for Ethereum, these mediator plus facade patterns simply don't work. For many reasons. Because every abstraction level, every further abstraction layer requires a lot of computation. That means more gas to perform the contract. Plus, there is this limitation on, well, why cannot we put together a single mediator that will be the upper entry point? That's the limitation on the protocol level, Ethereum protocol. Something trivially, there is a contract size limitation. So our mediator that can grow, that can develop, it might become too big, and simply it won't be uploaded into the network because of the size limitation. It's very difficult to manage dependencies and to restrict the access to SCs. That's indeed a very big issue, especially in a project as big as ours, where there are many smart contracts involved. I'll tell you more about our ways to handle this issue later on. The classical issue is that there's not enough tools for the development. Me being a developer from the web development domain, I have things to compare with, starting with inters, upgraders that format the code every step of the way, every line. So for every desire. So yes, I have things to compare, something that's missing now. The dev tools are scarce. So, how we fought dependency management? We wrote up our own abstraction. That abstraction leverages several methods. Set internal dependencies, set external dependencies. And that mechanism enables fine-tuning of dependencies between all SCs. At the lower tier, we have the storage. The lowest tier is storage, which is persistent. It's immutable. It stores all the data, all the tokens, ERC721, with dragons or eggs, or ERC20, the gold. That logic is not supposed to change. It's immutable. It is stored persistently. The presets are there. Next, there are several abstraction layers built on top of storage, which are responsible for manipulations in the game. Manipulations like events, in-game events, like fights, like auctions, all the rest. This is reached, or this is achieved through a dependence structure, internal and external dependencies between every layer in the contract. Internal dependencies or external dependencies show the contract what to address. For example, our abstraction depends on storage, and it wants to query the storage. Those internal dependencies help realize what is the address to query that storage. External ones, external dependencies, help realize which is the superior contract and which can be granted access to the data in that contract. This entire layout, this entire mechanism is also our solution. Why was it helpful to us? Well, because it was quite easy to set the initial dependencies with this mechanism. Abstract syntax tree could help us build a dependency graph between every contract simply by analyzing them, by analyzing their signature. And we could build a dependency graph based on that and install it. The initial deploy was very simple, essentially. So it's just several commands which collect the dependencies between the contract and set them into place. Further on, there is an upgrade controller which can govern these dependencies. It can switch external and internal dependencies between the contracts. This specific contract is owned by multisig. It's not a specific person. Further on, when we have completed the governance structure, this controller will be governed by the community. Multisig on gold token, ERC20. So this is the way we handle the dependencies issue. Now let's talk about the restrictions from the front-end side, which are arising out of our full decentralization path. We need to step away from the server-side rendering, and the users can basically make it happen. We decided to use client-side rendering. Again, this caused certain issues. How to optimize that? It's very difficult from multiple assets. It's very difficult to generate a dragon from multiple assets. Depending on the computer performance, it can take a couple milliseconds, up to 1 millisecond. Fractions of milliseconds to milliseconds. There are several cache layers which we can use. The first level, the first cache is cache API plus service workers. This is the caching asset we use. It works in the new browsers. I don't think the mobile Safari does that. Service workers are disabled by default. You must enable them in experimental settings. So the fallback to IndexedDB is used. It can help us store the blob. So that's one solution. And the third option, if nothing works, the available service workers are not working, then we can cache it during the session, at least. These pictures are cached within the session of rendered dragons. Not everything was smooth. We faced the issue of some parts of the dragons not being properly rendered. Well, how did we resolve it? The initial thought, the initial concept was computers of users were pretty powerful. It turned out that quite many people use their phones to play the game, or some outdated, some legacy computers which are not really performing. So we decided to give the possibility to change the texture quality for mobile phones. We can use them. We can use minimal quality textures for cell phones and a medium for all computers. That's the default settings. If the users want better appearance, they can simply go into settings and put or increase the quality of textures manually. Plus, there were some rendering issues that I mentioned. At some point, this was either related to poor internet connection, some sets were not properly loaded. Or the browser can simply hold the query itself. Maybe the browser could cancel them, and not all the parts would be rendered in that case due to browser caching issues. But seeing as how our game was cache sustainable or cache stable, once the user had rendered one thing, let me get it to this point. Yes, this is the way it's cached. To download this or to remove these pictures, clear cache button is there to enable re-rendering of a wrongly rendered dragon. If a person came to a room with stable Wi-Fi, then this clear cache can help fix any potential issues. Other front-end restrictions, it's bad UI UX. Originally, we believed or we relied on MetaMask's users, but it didn't, or it turned out it wasn't all that convenient. It wasn't all that productive. The MetaMask was not full-fledged enough. These pop-ups with confirmations, they are nagging. They are completely, they're a huge pain in the neck to monitor these transactions. So another point we came up with were the filters. Filters on the SC side, they're pretty difficult to implement, or it's not even feasible to do that. So to resolve these issues, what did we decide? We decided to add optional server-side filtering, meaning that it can be on or off as per user request. Yes, it's partial centralization, I get it, but it's optional. And again, in the future, we will make the open source, we will open the filtering server code open. We'll make it open source. And the user can deploy can appoint a specific feature to get this solution deployed on their side. Next, about poor UX, the issue with MetaMask, this nagging pop-up as to what are we going to do. What are we planning to? We're planning to add an in-game wallet, which is going to resolve many issues. So the gaming experience will be much smoother. What other limitations are there? The slow connections to the nodes for some users. Maybe ping could be sucky, the bad internet connection. What are the workarounds? What are the recommendations? The workarounds we used primarily for SCs to not use the iterations for large arrays, for long arrays. Don't do that. Ensure pagination. Do not iterate over long arrays. The more dragons we have, the more complex the query of this method will be, the request to this method. The query can become faulty with a higher probability, out of guess error will be. Use pagination. Well, it's a getter, but still there is a limitation. This method will operate slowly, proportionally to the growth of number of dragons. I mean, with every dragon, it will be slower and slower and slower. So pagination must be used for longer arrays. Alternatively, you can cache it into storage. You can write it into storage. Next improvement is potential caching of get logs responses. It's a fairly challenging method. Sometimes receiving logs of 2 weeks old can take dozens of seconds. So we cache that on the client side. We save the last block on the client side. We save the last cached block. And then we only collect the logs from a specific block. So bottom line, the first loading will be slow, sluggish. And the next ones, the next downloads will only require the data from the recent download. Like I said before, well, don't think that users' hardware is top-notch. There could be some legacy stuff out there. So we have decided to add a switcher that can switch the texture resolution. The minimal resolution, when used for slower devices, it really contributed to rendering performance. It's one of the solutions, potential solutions. Another point to be voiced, another front-end limitation, is a lot of fallbacks need to be written up. We've used WebSocket connections. The WebSocket connection was fairly unstable at that, so as a fallback, we decided to go for a block tracker, which is checking the current block. And it's updating the data over HTTP rather than WebSocket. So these examples, again, come in many flavors. The issue now is not everything is stable. So many fallbacks need to be written up, many workarounds need to be implemented. So that's a lot of extra work that still increases or boosts the stability of app performance. A few words about our battles, about our plans, about our battle plans. The gladiator fights, the gladiator battles are coming up. Yeah, they're nearly ready. Essentially, they're ready. So this feature is going to be added very soon. The gladiator battle is when a user can challenge or can put their dragon forth to a gladiator fight. Another user can accept the challenge, can apply to that, and they can they can wage bets on their dragon's victory. Other third parties, other users can also bet on the outcome of the fight. The in-game wallet I've mentioned is another future to-do item on our list. This is also going to improve the gaming experience. Dragon master page. Right now, you can share the dragon that you have. This same page will help aggregate all the dragons on the same page of the user. So you can boast, you can show off some dragons. And some governance. Yes, so the presentation about the game without the game, it's a small demo of how the fight is happening. This fight is generated by a smart contract based on RNG, some input characteristics of the dragon, its skills plus the tactics selected for the fight. That's just one example of the fight. Valer, is that your dragon out there? You can just explain that the dragon on the left used protection, and now the right dragon's attack is pointless. It's protected against it. Plus, they're quite far away from each other. You only see the long-range attacks. The strategy for the fight can be pre-selected before the fight begins. So if a dragon is better attacking, close range, long range, better defending, you can take all that into account. So this nyash-myash bit, the dragon has won and the other one has lost. Well, I guess that's it for our part. Any questions, please feel free to ask them. Thank you very much for your attention. Yes, there is Toля, eager to ask a question. Thank you very much for the presentation. Just one question. How do you select the dragons? Or how are you going to select the dragons for gladiator fights? The selection of dragons. Okay, for example, a user had really created a very good dragon. They have pimped their dragon out to a very high level. So he selects a dragon he wants to put up to a fight and then bets in gold or in Ethereum. The wage, bet waging. Then verifying the transaction, and then that user's dragon is in the active fights list. And now other users can see that fight created and they can apply to it. Any other user, when they apply, they also contribute the same bet amount, and they apply it to the fight. Accordingly, there is an interval during which it's possible to apply. So the user can preset the interval during which other dragons can apply to that fight. So once it happens, the user can either choose who to fight with, or if there are many people, too many people wishing, there will be auto-select. Too many people accepting the challenge. That will be auto-select. So you can do the extent. There are many mechanics that can be used. Bottom line, the user can determine who to fight with. So, there is a block of the fight happening. Before the fight happens, before the fight starts, other participants can bet on that fight, on its outcomes, and once that fight happens, first of all, the bets will be refunded. The bets, or the people who did not participate in the fight, or did not picked for the fight, they will get a refund of their bets. The rewards will be distributed among those who fought, whose dragons fought, and among those who bet on that fight. It's a fairly complex process. Why we decided to do it like this? Security. It's all about security. We cannot really use random number generator RNG based on hash block. We use the future block, or the block in the future. This enhances security, because in that case the miner cannot affect the outcome of the fight. So we appoint the block where the fight is going to happen. One limitation on the UX side: only during 256 blocks from this fight where you can perform this fight. It's just a simple technical limitation of the contract. Only 256 blocks to the depth. It's just an SC limitation. If these 256 blocks pass, you will need to extend the fight. Well, the flow is pretty complex. However, it stems from the RNG generation. We're using the block in the future, so this was the solution. Okay, beg your pardon, just wanted to clarify. Do you have any limitation for reply? I mean, somebody wants to pimp their dragon, the weak one, through gladiators, and somebody is putting the powerful dragons to those gladiator fights. Yes, there is a limitation for the power, for the level. Two strong dragons and two weak dragons cannot fight. This is pre-programmed. They cannot fight. And it's not just about well, promoting it or pimping your dragon. It's about making bets. Okay, so any further questions? I have a question for Maxim then, if nobody else wishes. How do you, what is your projection, distribution of eggs, when is it going to stop? Well, the penultimate 1,250 eggs will be every 8 blocks, and the remaining 1,250 in the 16 blocks. It could extend the distribution, possibly a week or two is when this distribution is likely to happen, to keep happening. Any further ones? Okay, none, thank you. Thank you very much, Maxim.